Welcome to a new test and teardown video. This time it is something very different. An electric microbalance weight scale called EMB1. So it consists of two units. One is the balance unit. And then there's a cable and a very special funny connector that goes to the readout unit. As far as I can see, you got this tray you can take out so you can clean it up, and if you're gonna drop some chemicals or scientific things, you can just take it out and fix that. Then you got these super thin, maybe this is stainless steel or something, but it is very thin. Obviously they tried to make this as low weight as possible, and they are exactly identical. You'll even see some tiny little, don't drop this, some tiny little calibration. See this here on the right? There's a little drop of something, and it's the same on the other one, funny enough. And they kind of go, let's see if I can get some light here. There's a tiny little needle on the top of that little sticky thingy. So this one should go on that needle like that. Oh, oops, oh, difficult. But, oh, I kind of missed it, but you get the point. It's supposed to be there. I'm so afraid of touching anything here because everything is so thin. But the idea is they can move up and down. And so you put, I don't know, a known weight and an unknown weight, I guess, right? And then you can measure how much is the difference, or if there isn't any difference, then you know you kind of got it, right? Then there's a mechanical lock for transport, and this will lock this system so it's not bouncing all the way up and down when you're traveling with this kind of thing. And so the readout unit, you can select how sensitive it is. Different ranges from 1 milligram to 200 milligrams. I don't know, so which one is the most heavy? The left or the right one? Or maybe this is zero calibration or something. I don't know exactly what that is. Here you can zero and calibrate, and this is of course the readout. And I guess you can measure the weight here, probably in milligrams, or so you dial this in, or how much is the difference from the known in this range or whatever. I haven't read the manual and I can't find anything online on this unit, no, not on this and not on that one. I've been googling around for a long time before I started this video, but there's absolutely nothing. So I'm kind of a little bit on my own here. So let's look on the rear side of the readout unit. This is the mains connector. This is an old English Bulgarian type of connector with protective earth. Just too bad the one that I got don't have the earth connection, so that means I will have to connect to the metal somewhere else, some way else, to get me a protection, because old stuff like this, there's most likely something wrong with the mains or something like that. So you could get an electric shock if you don't do that. So that would be the recorder output. That is something. So if you want to record what is going on, you could use that. A battery, so this one can run off a 12-volt battery. Suppression, is that mains hum or something like that? So this is where our fantastic connector goes. I can't remember I've seen this type of connector before, really. It is very old and special. So look at that. But it actually fits quite well, and this turn clicky locky, that actually works quite well, yeah. I see some corrosion here, and there was also corrosion in here, and I've cleaned it a little bit. So I think I need to take off the lid and have a look before I power this up, because I'm a little bit afraid of how it was stored the last many years. I don't know if you can imagine the word I just said real loud before I started this video, but it wasn't really pretty. Look at that. The corrosion here is just intense. No. That will be old batteries of some sort, right? Oh my God, that is bad. What type of batteries? I can't even recognize that because this is so badly corroded. Oh, I don't know if we got a new record here, but that is definitely really bad. Look at all that. So I'm happy I didn't plug this in. Oh no. And all the acids and stuff from all this corrosion actually also destroyed all this. No, okay, this is not corrosion, this is this. Okay, this is this crap from the top. This kind of dissolves and turns into slimy gunk if you wait long enough. So that I should be able to clean. But this, I don't know if I will be able to power this up. That is a new, I don't know if it's a new world record, but it is definitely a top score for the last 2 months, I guess. Boy, that is bad. Let's see if we can figure out how old this is, because I actually don't know yet. Look at the 4 PCBs. We're talking about germanium transistors. Sometimes you can find date codes on capacitors as well. Oh, this is old style. Oh, nice. So they're coated, so they can't be put in wrong. Oh, look at that tantalum. Isn't that just beautiful? So that will be all sorts of adjustments. That would be all the ranges. Of course, now that makes sense. So the range switches also. Okay, that will definitely be how that is done. Oh, they screwed it into the PCB. Oh, nice layout, by the way. That is beautiful. And the last one here. Ooh. Now that is cute. So that will be a bridge or a balanced stage, because look at that, the 2 emitters are definitely, yeah, the same point. Ooh, somebody performed service, added this trimmer. So there was a broken trimmer here, and that is a new one instead of that type that was broken. So yeah, and that capacitor here is very funny indeed. That is some. Hey, look at that! Look what I found. Let's see if I can get in here. 1952, isn't it? I think so. Haha, we got a date. That is exactly what I was looking for. Cool. Happy, happy. What are those batteries? I think we got the whole spectrum of chemicals and all sorts of puke. God, that is some really gross stuff. Oh, look at that. I was actually able to get the cells out of that thingy. Oh, that is some kind of chemical reaction. And all this I took away, so that is nice and clean. But look at those cells. So that is nickel cadmium. But what kind of cells is this? And 3 of them gives you what, 12 volts? How's that possible? Maybe there's a regulator here and it's normally running on a much lower voltage. I would assume though that is 1.2 volts, right? I don't know, but I need to clean this a lot more before we are done. Oh, yikey. I think that was enough cleaning just to survive being near this thing. Yeah. And by the way, I took a few really nice close-up pictures of this label, and now I think it is 1962, and that gives us 10 more years after the release of the germanium transistor. I believe most of it is actually germanium transistors, but look at that. BFY 20. So, and that's both of these. So that's actually double NPN silicium transistors. So, and I think they were actually released in the 60s, right? In the start of the 60s. So, and if you look at this circuit with the double transistors, everything here is actually double transistors. And look at the way it's connected. So, what I think we got here is actually an op amp. Look at that. So that would be the 2 outputs. And here we got the 2 inputs. And that will be power supply, right? So, an op amp in a board. I like the way that everything here is coated, so I'm not super afraid I'll stick in stuff wrong. So now I will prepare for the first power up, and hopefully it's gonna work. Oh yeah, there's a label missing here, and I believe this is input voltage selection. I did of course mark the position. So look at that. So this is in a tube socket. Can't pull this out, it's locked, and then you can flippity floppity this one. But I think the idea is you put it either there or there. That will be the 2 valid positions, and anything else is gonna cause you all sorts of short circuits and meltdowns. I believe the way to service this is just to unscrew the 4 screws here, and then the bottom can come off. This will also let me clean up and inspect a little bit better. So I might do that. Ooh, I still don't want to touch anything here. See, I didn't clean it good enough. So now we'll go outside and do the rest of the cleaning here. Ooh, no, it looks like some of this goop went into the 2 pots down there, and those are needed for, that will be, okay, so this is just the recorder outputs. So that means I will be perfectly fine, even if those pots are damaged. Yeah, and you see the wires from the voltage selector, they go to the transformer, so I should be pretty fine on that. So that will be the AC outputs going straight to the first board. So that is of course the power supply board. Oh, see the detail here about the wires? That's actually rubber bands. Isn't that just cute? Let's just have one more look on the power supply. That will be germanium PNP transistors. So this is the center. So all we got here is just 2 emitter followers, and that's it. Nothing more, no regulation or anything. And by the way, I just measured the capacitor. It's more than double. Isn't that amazing? After that many years. One little detail bothers me a little bit, and that is the way that the batteries, they're implemented. I don't know if this unit will actually work without the batteries, because look at that. So that will be 1 cell and that will be 2 cells. So I think we got like a positive negative kind of voltage supply system going on here. So really, I don't understand how this is, the voltage rails for everything here, how this is working. But that will be center tap. That's actually the positive. You can see here how this is done. So the center tap goes straight to the positive. Well, that's a little bit funny. So the 2 AC windings. So that probably the black one here. I don't know where that is going. Let's just power this up and see what happens. So we are ready to power this on, and I will connect mains voltage and I will turn this on. 8 watts. So what exactly is this? I don't see anything here. Ooh. That is something, right? Oh. Okay, this is how much the meter can. So let's see if we can see this. This is the 0? No? Okay, this is doing some stuff, right? How about if I try and move this one really, really careful? Oh yeah, my God. If I go up or if I go down? Oh, this is so sensitive. But damn it, it works. What if I crank this mechanical 0? A little bit to the left or the right. Ooh, hoo, hoo. Yeah, this thing works. So how the heck is it actually working? I really wonder what is inside the sensor. Because now we kind of know what this is doing, right? So we've got an op amp that is measuring some differences in some fancy stuff in here. So is there like is it optical or is it, how is this sensor working, really? That is what we need to find out now, right? I've been playing a little bit with this. I just needed to continue with the video here. So look at that. So this is only in the 10 milligram range. And this is a piece of paper. I don't know if you can imagine. This is really, really lightweight. And there's got no momentum in any way, right? So if I take this and just touch with the tip of this one, and you have to look here, right? At the same time, so look at this. And I'm just touching it as little as I possibly can. See, a little bit down and a little bit up. Look at that. It is that crazy. I mean, this thing works, god damn it. How do I find something that is exactly 1 milligram or 10 milligrams or something like that? That is going to be a challenge, because I got no clue yet. But I know how heavy this paper is per area. So how about I could cut some pieces of paper and put on each side and see if it is able to measure that. That could be a way, right? I think I finally figured out how to disassemble that thing. See, this is the transport lock. It's connected to this one. And I was able to pull it so it could be released. I think somebody tried to glue it, but there's a set screw down there and I am not able to figure out how to get that out. Damn it. So anyway, now I pulled the whole measurement balance kind of thing out. It's actually quite heavy. The reason for this for being white, that is of course now you can see what you're doing in here, because it's going to be very, very dark. They could have made a transparent lid or something here so we could see something. Or why isn't there any little bulbs or lamps and stuff in here? Maybe it's because they don't want to heat up anything, because heat will cause air to transport around here, and we don't want that at all. So that is probably why it is made this way. Measuring milligrams is insanely critical, and this is why there's this airtight lid with a rubber gasket all the way around here, and you can even lock it like this and then perform your measurements. It's probably going to take some time for this to stabilize. So now let's look how this really works. There is a bulb in here, and I believe we got like a shielded cable. So there's probably an LDR or maybe two of them, light sensitive resistors, in here somewhere. And we also got two resistors here, right? So, or maybe there's a bridge. So you add some light. So there's definitely light in this thing. So to be able to change the light bulb, how do you do that? Maybe if we remove the rear plate, we can see what we're doing here. So that is the rear plate removed. We got some resistors and a nice shielded cable that is also connected to the chassis here. But in here we got only one wire. What is that doing here? Okay, so this is a, yeah, okay, a shielded cable. Where's the shield connected? So that was a little bit better, right? So we've got 4 wires. It's a little bit crazy with the wire coding. So the yellow one here goes to the black one. The red is the purple. And there's a resistor. Oh, the green one is here. That's connected to the common point of the 2 resistors. The blue one goes to the brown one, which is also one of the resistors. And the bulb got their own. Oh, there's also a white one. Ooh, what is that magic white one doing? Oh, we got some more fancy shit in here. Oy, 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 oy. Look at that lamp unit. The way that I definitely want to open this a little bit more. Maybe we just take out those 4 screws and have a look, right? I mean, this video just gets better and better every second. I was just laughing so loud. Look at all the funky stuff we got here. And the lamp unit and the lens. There's a mirror. And the mirror go down to what have you got down there. Look at that piece of funkiness. So it hits a mirror and then it goes up to some detectors, right? Now that is some. What is the idea with that wire? Ooh. This goes to this one. But why? Man, I need to look a little bit more on this unit before we close this down. There's also a little funny here. What is that? Ooh, there's a screw here. You can do the adjustments of some stuff. And you can adjust this screw and move this mirror. I'm totally not touching anything here because the unit actually works. So we don't want to screw this up. But it is actually possible to take this and touch it. So careful. They only move this little, right? Then let's see if we can figure out what is going on in here. Got some stuff. Aha, the mirror is connected. Hang on, I'll see if I can hold the camera. I think I finally figured out how this thing works. If you look really careful. Oh, by the way, that's actually the needle point. Can you see how tiny little that is? But anyway, so that is a galvanometer. That is an insanely sensitive meter. So when you apply current to the windings, it moves in each direction, right? If you look at that mirror and the 2 sensors up here, there's actually a thin metal line between them. So that means when light moves between the one to the left or the one to the left or right, the resistance changes in these 2, right? So the electronics is aiming to make those exactly the same. So when you apply weight to one of them here, you need to apply a known current. So it will be equal again. And that is why this instrument not only is able to measure the balance of stuff, but it can also measure how heavy something is without having a counterweight on the other one. Isn't that just amazing? So here's the light source and the optics for that. And then it hits the first mirror like that. So this wire here is actually one of the contact points for the galvanometer, and there's a thin little wire in here. Let me see if I can focus on that. So that wire is actually the spring as well that holds the coil in the middle where it's supposed to be. And when you're dialing the mechanical 0, you move this spring a little bit to the left or to the right. It is really beautifully made. And this is the other end of this spring, and it of course goes to another wire. So that will be the two contact points for the coil. I have actually found the mechanical bug and the problem, because there is a little bit of a weird mechanical hysteresis when I'm applying weight to each of the sides. And if you look at this tiny little here in the very middle of the picture now, can you see it's broken? There's a little bit of glue here, and that is broken, that little piece. That rod should be glued right there. Now you see it really loud and clear, right? So somebody added too much weight. You can even see how the beam is bent a little bit. And that is why we have those two stops there. That is to prevent you from overloading, because the entire weight of the two test objects, they're actually hanging in the thin wire to the coil. But this should be completely free. As you can see here, it is not. And that is because this center thing is just barely touching the magnet. So that is the problem. How the heck can I fix this? I don't know. I need to release the spring, and then I need to move the alignment point. Probably that screw will release that one to the left, right, and the other end of the wire here is soldered in here to the white wire, and that is a little springy piece. Damn, that's difficult to show. But at the end there's a tiny little soldering, and that is what is holding the wire. So if I loosen those two screws, I will probably loosen that wire, so I can add a single drop of glue in there. Epoxy probably. Maybe I could fix this. That could be so cool. So the last few days I've been playing with galvanometers, so that means I am prepared for what I see in this one. So that is a huge advantage. By taking away the 0 knob, by the way, that is a Bakelite as well. That will give us access to the solder point of the other end of this wire. So I need to move this a little bit that way so I don't have any tension. And of course I need to recalibrate this, because as you can see here, it is already a little bit too much to the right, and that is why it's touching the magnet part. And so I need that 1/4 of a millimeter to the left. And I also want no tension on the wire while I'm doing the soldering, and I want it to be in the very center. So how the heck do I do that at the same time? I believe this screw will let me push in this part. So if I loosen that screw, I will be able to loosen the tension. But maybe I also need to loosen the tension on the other one. And how do I align them? I don't know, this is a challenge. But so far I got something that is not absolutely perfect, and I want it to be perfect. That was difficult. I'm using one little straw of wire, and then I attach this tiny little amount of epoxy, and then I go all the way in here and add epoxy in between here where it was getting loose. And of course I released the tension in the connection springy wire. As you can see here, the front is actually bending a little bit down, so it's completely loose. I had to desolder that point and move that wire a little bit, because that's the only way I know I could move that end of the coil a little bit closer, and this way release that point from touching the magnets. And I released I loosened the two screws in here to release the tension. It is taking an enormous amount of time, but I think this is really worth it. This is going to be a lot of fun playing with a weight scale that can handle milligrams. So now it is assembled again after the glue is hardened in here. I put the tension back into the string and all that, and look what we got. If I blow a little bit of air on this one, let's see if you can see this. Can you see it goes like it's completely free? It's actually moving like that. So now I'm going to assemble everything again, and now we can perform some measurements. That is going to be interesting. Let's see if I'm able to get this on video. I am in 20 milligram range, and I've poked a little bit with this. Let me try and put 1 milligram on the right side and see if the needle is going to the right side. Ooh, I need the better glasses. And wish me luck. This is difficult to do. How do I drop this without? So it is actually the weight of the paper that is causing this. That is not easy. Yeah. So now it's there, and we didn't see anything, did we? So that means I need to go down into range. It is all the way out to one side now. That sucks. So I should be able to fine tune. It is really, really difficult to find the mechanical zero, as you can see here. Whoa. I think the idea is you only need to be quite close to the mechanical zero, and then, see, it is right here, right? and then you should be able to use the 0 button here, but that one is not working. So there's also an electrical problem with the amplifiers. So now let's see where it is, and now I'm going to lift away my 1 milligram. And then it went all the way out. See? If I just lift it. I don't know what to say about this. I really thought that I fixed this mechanical thing. See, now it is hanging in mid-air and is super good. I don't know. I don't find it any more fun to play with this anymore, by the way. Since there's this, and I don't have any schematics, and it's going to take me 2 more days to trace this and figure it out. And there isn't really a lot of electronics here anyway, and it seems like it's more or less so close to be working. So I think the next owner will have the pleasure of figuring this out, but I mean, we are really close. And I don't have any cool usage for this weight scale. I don't know really what I can use it for. It was only fun to play with it anyway, so I think I will call it a quit. And let's close this beautiful unit and put it up for trade.